In this lesson, we are going to be going over how to solve problems using trig ratios. So if you recall, the trig ratios are as follows. Sine theta, or sine of an angle, will always be equal to the length of the opposite side divided by the hypotenuse. Cosine of an angle will be equal to the adjacent side divided by the hypotenuse. And tan of an angle will be equal to the opposite side over the adjacent. Now, we've been talking about the unit circle, so one thing, and forming triangles within it, so one thing that you'll notice is if I were to draw an angle here in quadrant 1, and I were to find sine of this angle, the opposite side is over here, and this is the y value. And the hypotenuse is here, which is the radius. So you'll notice that sine of theta is opposite over hypotenuse, and in the context of these circles, we would be looking at the y value over the r value. Similarly, for cos, the adjacent side is going to be this length here, which is equivalent to our x value over the radius. And for tan, opposite over adjacent, we have y over x. Now on our unit circle, what you have to remember is that r is always equal to 1. So if we substitute 1 into the bottom of these, you'll see that it follows that sine theta is equal to y, cos theta will be equal to x, but then tan theta is still y over x. So that means that on the unit circle, the coordinates p of theta can be written cosine theta, sine theta. And if we connect that back to our unit circle, you remember we have those coordinates x, y. So if I were to ask you for the cosine of an angle, you could look for the x value in that coordinate. Now, we also have to include reciprocal trig functions. And these reciprocal trig functions are cosecant of theta, which is equal to 1 over sine theta, secant, which is equal to 1 over cosine of theta, and cotangent, which is equal to 1 over tan theta. So these are just the reciprocals, 1 over each function. It's really, really important that you know these three, that you know that cos is x and sine is y, and that you know that tan is y over x. It's going to be critically important. So, if we look at example 1, it says the point -3 over 5, -4 over 5 lies at the intersection of the unit circle and the terminal arm of an angle theta in standard position. So this point is here on the terminal arm forming this angle theta. Draw a diagram and find the ratios for the other 6 trig functions. So if you notice here, we have an x value and a y value. Now, because they're both negative, that means that we are in quadrant 3. So if you sketch this triangle, you'll see your x value is -3 over 5, and your y value is -4 over 5. And because we're on the unit circle, we know that the radius will be 1. So when you're looking to find cos of theta, remember that's going to be your x value, so -3 over 5. For sine of theta, it's your y value, so -4 over 5. And for tan, it's y over x, so -4 over 5 over -3 over 5, which simplifies to 4 over 3. I believe there might be an error in the notes for this one, so just double check you have the right value written there. Now for our reciprocal trig functions, we have secant, which is 1 over cos. So it's the reciprocal of 1 over cos. So instead of -3 over 5, we have -5 over 3. For cosecant, it's 1 over sine, so -5 over 4. And for cotan, it's the reciprocal of tan, so 3 over 4. So those are all of our trig ratios associated with this angle and triangle. If we go to the next page, you'll see here that it says that cotan of theta is equal to negative 12 over 5. And sine theta is greater than 0, meaning it's positive. Find the 5 other circular functions. Circular functions refers to those trig functions. So that means sine, cos, tan, as well as their reciprocal functions. So first thing that you need to do, the first thing that I did, was cotan of theta is negative 12 over 5. That means that tan of theta is going to be negative 5 over 12. Sine, cos, and tan are definitely a little more useful to work with, so I made that switch right away. So I see here that tan is negative and sine is positive. And the only quadrant where that is true, if we use our cast rule, cos, all, sine, and tan. So we're looking for where tan is negative but sine is positive, would be in quadrant 2. So when you go to step 2, in order to figure out your other circular functions, you have to be able to sketch this out. And you need to know your x value, your y value, and your r value. This question did not say that this is on the unit circle, so you can't assume that r equals 1. So in order to do that, we're going to draw a triangle in the second quadrant. So I drew that here. And from tan, we know that tan is y over x. So if tan theta is negative 5 over 12, when you draw this in quadrant 2, remember this negative can go with either the x or the y value. If we're in quadrant 2, it means the negative is the x value. This x value is negative, and the y value is positive. So this would be negative 12, and this would be 5. Now we can use Pythagorean theorem to solve for r. And once I've solved for r, then I'll be able to find sine theta, cos theta, tan theta, and their reciprocal functions. So you'll see over here, I have r squared is equal to negative 12 squared plus 5 squared, which is equal to 169, which I then square root to get plus or minus 13. Now, if you were solving for x or y, you would want to be careful to select the correct sign, either positive or negative, and our radius will always be positive. So r is equal to 13. So now, when you go in to solve for sine theta, cos theta, tan theta, you're going to use y over r. Now, the key difference between the last example we did in example 1 was that this told you that this laid on the unit circle. That's why cos theta was just equal to x. If you notice, we could do x over 1 for cos. X over r would be x over 1, which is just equivalent to negative 3 over 5. We could do y over r for sine, would be negative 4 over 5 over 1. But in this example, the radius is not equal to 1. So that's why for sine, I'm using y over r, which is 5 over 13, and its reciprocal, 13 over 5 for cosecant. Cos theta is x over r, so negative 12 over 13, and its reciprocal would be negative 13 over 12. And tan is y over x, so 5 over negative 12, and its reciprocal would be negative 12 over 5. If we go to the next page, very similar, but this one is telling you that sine theta is 5 over 13, and that theta is between pi by 2 and pi. Remember, this is the equivalent of 90 degrees and 180 degrees. That means we're in quadrant 2. Find the values of the other 5 trig ratios. So again, I drew a triangle in quadrant 2, and sine is equal to y over r, so 5 over 13. I'm then going to solve for the other side, And you'll notice this is actually the same triangle as in the previous question. But in this case, we're solving for x instead of solving for r. So you'll notice here that I get x is equal to plus or minus 12, but because I'm in quadrant 2, x is equal to negative 12. So again, to write out your ratios, sine is y over r, cos is x over r, tan is y over x, and then their reciprocals are there. So you can see how example 3 and example 2 are actually the same, but you'll notice how the information that's given is quite different. If we look at example 4, it's asking you to determine the coordinates of the point P of theta on the unit circle if it also lies on the line from the origin to the point, and there's two different points it's going to want you to work with. So here, we're looking for the point 4, 3, and we want to find the coordinate of this point on the unit circle. So the first thing that you'll notice here is you'll notice that 4, 3 would be an x value of 4 and a y value of 3. You could use Pythagorean theorem, which you'll see I did here, to determine the radius. 4 squared plus 3 squared is equal to r squared, which means 16 plus 9, or 25, is equal to r squared, so r is plus or minus 5. That means this entire radius would be 5. But I'm looking for the equivalent point on the unit circle. Now, if you recall, when you're looking at similar triangles, in a similar triangle, all the sides can either be multiplied or divided by the same number to create a similar triangle. So in this case, this has a hypotenuse or a radius of 5. I want it to have a radius of 1. As long as I shrink down all the sides by the same proportion, by the same value, I will create a similar triangle where this angle will be the same and the ratios among the sides will be the same. So if I wanted to shrink this down, this has a radius of 5, I'm going to divide by 5. That way, my new radius for this similar triangle on the unit circle is 1. But if I divide this by 5, I have to divide these sides by 5 as well. So the y value becomes 3 over 5, 3/5, and the x value becomes 4/5. So the point that's on the unit circle that lies on this line, so this point right here that lies on this same line, would be at x is 4/5 and y is 3/5. So I've just taken that triangle and shrunk it down to have a radius of 1. Very similar for question B. In this case, we've got the point negative 5 over 6. So again, using Pythagorean theorem, we would determine here that r is equal to plus or minus the square root of 61. This means that x would be equal, now I didn't draw out the triangle in this one, but if you wanted to include it, I'm short on room here, we've got negative 5, 6, so we'd be in the second quadrant, negative 5, 6, and root 61. So you would have to shrink this in, you would have to divide by root 61. That gives you a denominator of 1, and then your x value is negative 5 over root 61. Your y value is 6 over root 61. Now, if you recall, we don't generally leave roots in the denominator, so to rationalize the denominator, you multiply by root 61 over root 61. You end up with a mixed radical on top, but the bottom is a nice whole number. So you do that for x, and you do that for y, so that you get your point of negative 5 root 61 over 61, 6 root 61 over 61. And one more example here. Well, a few more examples, but one more idea here. And this is just a good reminder of using the unit circle for some of these special values. So when you're looking at finding the exact values for some of these trig ratios, you can use your unit circle. So sine of 7 pi over 6, this is on the unit circle, it's equal to, this means sine of 7 pi over 6 means the y value at 7 pi over 6, and on our unit circle, the y value at 7 pi over 6 down here is negative a half. Here we have sine of 7 pi over 4. Again, that means the y value at 7 pi over 4, which is negative root 2 over 2. Cosine at 330 degrees means the x value at 330 degrees, which is root 3 over 2. Tan of 2 pi over 3, remember tan is y over x. So at 2 pi over 3, the y value is root 3 over 2, and the x value is negative 1 over 2. You need to divide those two, y divided by x. To do that, remember when you're dividing fractions, you're going to flip and multiply, and you end up with negative 2 root 3 over 2, which simplifies to just negative root 3. Cosecant, remember cosecant is equal to 1 over sine, which is 1 over y. So on your unit circle at pi by 3, the y value is root 3 over 2. So 1 over root 3 over 2 would be 2 over root 3, but then you're going to rationalize. So multiply by that denominator, and you get 2 root 3 over 3. Similar for secant of negative pi over 6. So secant is 1 over cos, or 1 over x. And negative pi by 6 would just be backwards pi by 6. It's equivalent to 11 pi over 6. And we're looking for 1 over x. So again, 1 divided by root 3 over 2, which we had just done in the previous question. And then finally, the point at 17 pi over 6 means both x and y. 17 pi by 6 is going to be at the equivalent of, where are we? Here, 5 pi by 6. If you subtract 2 pi, or 12 pi by 6, your equivalent point is here. This is the same for these special values here in that cos. If you notice, these ones were all on the unit circle in the quadrants. These ones, 3 pi by 2 is on sort of our vertical here. Think of it like the axis. So cos at 3 pi by 2 is the x value, which is 0. Cotan of 10 pi, well 10 pi would be coterminal with 2 pi. So it's coterminal with 2 pi, because we would go 2 pi plus 2 pi is 4 pi, 6 pi, 8 pi, 10 pi. They all land in the same spot. And cotan is x over y, which is 1 over 0, which is undefined. 7 pi is coterminal with pi. So pi, 3 pi, 5 pi, 7 pi would all land here. And cos is the x value, so negative 1. And then tan of negative 15 pi over 6 is equivalent to, if you wanted to add 2 pi, you would get, so I'm going to do this here. If you wanted to add 2 pi, you would have negative 15 pi over 6 plus 12 pi over 6 would be negative 3, plus 12 pi over 6 would be 9 pi by 6, which is equivalent to 3 pi by 2. Okay, so you have to do that in stages. And here, tan at 3 pi by 2 again is x over y, which is, tan, y over x, negative 1 over 0, which is undefined. And then in example 3, you're just going to put all of that together. Here, you're looking for the x value at 5 pi over 3, which is half, the y value at pi by 6, which is half, and the x value at pi, which is negative 1, and squared. So here, it means cos of pi squared, so negative 1 squared, and then you're just going to use your arithmetic. 1/2 plus 1/2 minus 1, which is equal to 0. And then same over here. Sine at 4 pi by 3 is the y value at 4 pi by 3 times cotan of pi by 6. So cotan of pi by 6, you might want to do some work on the side. Cotan is x over y. So we're looking at root 3 over 2 over 1/2. In the end, it equals 3 over root 3. And cosine at 5 pi by 4 squared is negative root 2 over 2 squared. And then you would multiply these and add. You get a total of negative 1.